Yesterday we have
Antti, I
discussed.
have a question.
Right.
Like when I was downloading the Tableau on my computer, the
Mm.
newest version wasn't working for some reason.
Mm-hmm.
So I downloaded like 10.5 today. Would that work? Is that fine?
Yeah, that's okay. That's pretty okay.
Yeah, I just downloaded today, so I'll get that done. Yeah, it wasn't working. So,
No issues.
and
10.5
the
is
reader is fine, right? The reader I can download anything, or is it like do I get 10.5 for the reader also or something?
yeah. So you maintain the same version for reader as well.
Okay, thank you.
Okay. Right. Right. Yesterday, so we have discussed about Tableau desktop environment. So basically, we have seen that in Tableau desktop environment, there are two sections. One is a data section, another one is a workbook section. So in data section, that we have seen that there are dimensions, measures, sets, and parameters. So in the workbook section or the Tableau workspace, so we have seen that there are a few components of it. So one of the component is the shelves. So we have seen that there are columns, rows, pages, and filter shelves. So we also seen what is a marks card and what are the different components of it. And we have looked at toolbar and different seen how what are the different tools and what are their functionalities. And we had seen different sheets, be it a worksheet, dashboard, or a storyboard. So we've also seen show me and what are where we use it and what are the uses of it. Okay, so we have seen that there's a status bar here. So whatever are the uh, number of columns or number of names. The status bar shows the number of rows and whatever is the status of the view that you are seeing. So we also seen some important note points to remember. So go through that class, and later on we have built some basic visualizations using training superstore sales data. So this training superstore sales is the Excel data source that we have used for building a few of the tasks. We have worked on the tasks yesterday. So to understand basic visualizations first. So we have done 11 tasks yesterday to build basic visualizations. So I've asked you to practice those tasks. So have you done that, everybody? So the prerequisite
Yeah,
task.
as I told you, I didn't get a chance because it wasn't working for me yesterday.
Okay.
So I was looking at the options, and today it's like my download 10.5. So I will do it today after class.
Yeah. So in this weekend, I mean, please do practice those visualizations going through the recordings. I believe you received my mail regarding the recordings of the previous 3 classes. So we'll also be sharing today's class. So over the weekend, I mean, please practice those visualizations so
Okay.
that you are ready for the next week. Okay. Right. So today, so we will be looking at few of the uh, working modalities with dimensions and measures. So first, before that, we will try to understand. We'll try to understand the behaviors of a dimension and a measure and different data types in Tableau. So I've given a few uh, introduction about different visual cues. So we'll go into detail about that. So first, we'll try to understand the behavior of a dimension. So what is a dimension here? So it's a it's a discrete value. So dimension always contains discrete or distinct values. So customer name is a dimension, right? So it contains discrete or distinct values. So what is a distinct or a discrete value? So distinct or discrete values means so each and every value will be independent of the remaining values. So if Aaron Day and Aaron Dylan is there, so they are independent of each other, right? So each and every value in a dimension will be independent of each other or independent of the remaining value. So they are unique members, right? So a dimension contains distinct or uh, detail or discrete values. Okay, so whenever you drop a dimension into the view, either in columns or rows, so they appear in blue color like this. They appear in blue color like this. So that is a visual cue. So by seeing a blue field, you can identify that it is a dimension. And always a dimension will be in non-aggregate way. So they are actually showing each and every value in the view, so they are not aggregated. So a dimension is always by default it's a non-aggregate field. Okay, a dimension is always a non-aggregate field. Okay, so if you are using a order ID or customer ID, you can make it as a aggregate by using a count distinct or a count function. However, by default, they are non-aggregate field. If you first drop any dimension into the view, they will be non-aggregate. They will be shown as in a non-aggregate way. So uh, if you show any discrete field, Tableau always displays a header for it. So for example, if you use sales for it, okay, and use a visualization, so it always shows a header like this. So if you hide a header, so you don't have all the values. So basically a discrete field or a dimension always shows a header. Header means showing the values within the dimension. So by default, the behavior is that for discrete fields, Tableau always displays the header like this. So this is about the behavior of a dimension. So coming to the part of a measure, so what is the behavior of a measure? So measure always contains continuous values. Okay, here sales is a measure. Sales is a measure, right? So sales is a measure. So it always contains continuous values. So what is continuous value? Continuous values means each and every value will be dependent on the remaining values. So continuous values means, so each and every value will be dependent on the remaining value. Okay, so it has 1 to uh, 1 lakh 119. So it's a continuous value. So that means each and every value will be dependent on the it's a continuous measure here. So each and every value in a measure will be dependent on the other value. So whenever you uh, whenever you drag drop a measure into the view, so it appears in green color. It appears in green color. Okay, so green color is a visual cue to identify a measure. So it also by default is shown in as an aggregation. Okay, because it's a continuous field, uh, a measure by default shows as a aggregations. Here in this example, sales is a measure and it is shown in the view, and the aggregation, default aggregation is sum here. So it is summing all the values from 1 to 1 lakh 119, and it is showing as a sum. Okay, so the aggregation here is sum. Okay, so by default, continuous value will be shown in an aggregate way. Okay, so also one more point here is, so for continuous fields, Tableau always displays axis. So Tableau always displays axis for continuous fields, and for dimensions it displays headers. For dimension it displays headers, and for continuous fields Tableau displays axis. This is the axis, right? So this is the axis. Okay, so for continuous fields, Tableau displays axis, and for dimensions it displays headers. Right. This is about the behavior of a measure. So now we are going to look at different data types in Tableau. Okay, we are going to discuss data types in Tableau. Okay, when you come to the part of dimensions, within dimensions, we'll see different data types. Okay, so if there is a ABC which is prefixed before a field name, so that means in under dimensions, if there is ABC uh, as a prefix, it means that dimension is a textual dimension. Okay, customer names contains what? All these text, right? So if ABC is prefixed before a field, which is a dimension, then that dimension is known as a textual dimension. Textual dimension, because that dimension members contains text as data, right? If you see globe as a prefix before the field name, so then that is called as a geographical textual dimension. So under a dimension, if you see a globe as a prefix before the field name, then that type of a dimension is called as a geographical textual dimension, right? That is called as a geographical textual dimension. So for example, state is a textual dimension, geographical textual dimension. So if you see a state, so is it not shown in as a text here? So the state is a text field, also a geographical field. The state is a geography, right? So it is represented with a globe icon as a prefix before the um dimension name, right? So if you see a calendar icon, if you see a calendar icon, that means that is a date dimension. So if you see a calendar icon as a prefix before that, before a dimension field, that means it's a date dimension, right? So okay, so basically, if you if it is a uh, if it is a if it is showing a calendar, then it's a date dimension. Similarly, if uh, if it is showing a prefix of a icon which is calendar plus a clock, so that means it's a date plus time dimension. So here string date is a date plus time dimension, which is showing a icon with a calendar and a clock in it. So as you can see, so it is having date plus time as a dimension. Okay, so we can identify a date plus time dimension by seeing a calendar plus a clock icon. So similarly, we have, so if it is a globe, uh, it's a geographical textual dimension. So uh, if it is a calendar, that's it is a date type. So in under a dimension, if you see a hash symbol like this, then that is a numerical dimension. So order ID is a numerical dimension, right? And also row ID is a numerical dimension. Also customer ID is a numerical dimension. If you see a hash symbol under a dimension field, so it's a numerical dimension. See, if you so all the numbers are there. So these are different customer IDs in customer ID. So if the icon is showing hash under dimension, that is a numerical dimension. So if ABC is there, so then it is a string dimension or a text dimension. And if you duplicate any field and there is a equal symbol, then it is either a duplicate or a calculated field. Okay, so if you prepare a calculated field also, so for example, if you create a brand calculated field, that is also represented with a equal symbol. So it's either a calculation or a duplicate of another field. Okay, so this is about different um, data types in under dimensions. Now we will look at different data types under measures. So under measures, if you see a hash icon, then that is a numerical field. Okay, so here uh, discount is a numerical field, right? Discount is a numerical field which is represented with a hash icon like this. So if you see a globe under a measure, then that is a numerical geographical field. It's a geographical numeric field. Okay, so if you see a globe under measure, then that is a geographical numerical field. Right. So these are the different data types in Tableau. So and these are different visual cues that you can see. So as you have seen, the visual cue or appearance for a dimension is blue. Okay, and the visual cue or appearance for a measure is green. So it is possible to convert text or geographical dimensions into measures. So we look at few other scenarios where it is possible to convert a text or a geographical dimension into measures. Okay, it is possible to convert a text dimension or a geographical dimension into a measure. It is also possible to convert measures. It is also possible to convert measures into dimensions. Okay, and we can even convert their behavior to discrete. For example, discount is a continuous measure. So it is possible to convert a measure into dimension. So we can convert that a measure called discount into dimension by clicking on this. We can also convert the behavior of a discrete measure into a continuous measure or a continuous dimension. So if you click on just continuous, so it will become a continuous measure. So if you click on convert to continuous and then convert to dimension, that then it will become a continuous dimension. Okay, so we can convert a measure into a dimension, and we can also convert the behavior to either discrete or a continuous field. Okay, so it is also uh, possible here. Okay, so however, it is not possible to convert a date or date plus time dimension into measures. So we have date fields here, right? So order date is a date field. So it is not possible to convert a date field into into measures. So date field will always remain a dimension. Okay, so we cannot convert a date field into a measure. Or okay, or we cannot convert a date plus dimension. We cannot convert date plus dimension into measure. So we cannot see, there is no option to convert into a measure. So date and date plus time measure dimensions will not be or it is not possible to convert them into measures. However, we can convert their behavior to continuous. So we can convert their behavior into continuous. Okay, so they are discrete now, so we can convert them into continuous. So order date, here also we can convert their behavior into continuous. Okay, but we cannot convert them into measures. Okay, so if you want to convert any field from dimension to measure or measure to dimension, what should we do? uh, we have to right click on those dimension or measures and then click on convert. Okay. Okay, if you convert any field from dimension to measure or measure to dimension, the behavior of the field will change. Okay. Okay, if you convert a discount to dimension, so dimension is now a discrete. uh, okay, so by default it should be a continuous. Okay, I've changed it. Okay, so we'll see sales. It's in discount it should be continuous. Okay? So in sales, uh, so by default the the behavior is uh, it is a continuous. So if you convert sales into dimensions, so we'll see what happens. So now we are converting um, uh, a, a field from measure to dimension. So sales has been converted from measure to dimension here. So it was in measure, now it is in dimension. Okay. So if you convert measure to dimension, the behavior of the field will also change. So now the behavior will also change. So we can change that to measure also. Okay. So at times it will here. So we'll see one more example. So if you convert a dimension to measure, so now we can see that um, it is discrete in nature, and also we can convert that into continuous. Okay, we can convert that into continuous, or even we can make it into a discrete one. Okay, right. So how to convert a dimension into a measure, or a measure into dimension? So you have to right click of any field and then select convert to dimension or measure depending upon the field type. So if you just convert any field into continuous and discrete, they will exist in the same place. That is, they will exist in measures or dimensions. So for example, if you take profit, if you just convert it into a discrete, it will become a discrete measure and it will stay here itself. Similarly, if you convert a dimension into mm, if you convert a dimension into a measure, if you convert a dimension or a just as we'll see one more example. So these are all changed, right? So if you change them, so the behavioral will be like they will exist in the same place, that is either dimension or a measure place. uh, However, if you convert them into dimension or a measure, they will change the place from dimension to measure and measure to dimension. Okay, right. So while working with dates, we'll always use continuous dates. Okay. So while working with dates, it's always recommended to use continuous date to show uh, the progression in time, or time series. So uh, if you turn a field from discrete to continuous, all the header values will display. Okay. And in the form of a axis. And similarly, if you turn a continuous to discrete, um, then it will show as a discrete axis. They will be displayed in the form of a header. Axis will be displayed in the form of a header if you turn um, continuous to discrete. Similarly, if you turn discrete to continuous, all the header values will be displayed as a axis, because for continuous values we have axis, for discrete values we have headers here. Okay. So these are the different data types in Tableau and how you can change the different data types. Right. So now we are going to see how we can work with multiple dimensions. So in Tableau, rather than using just a single dimension, so we can use multiple dimensions. Okay, so we'll open a new workbook. Try to connect to a data source called training superstore. And orders is the table that we are using. Right. So now we will try to work with multiple dimensions. So in Tableau, to work with multiple dimensions, we have two ways. One is nested table and the other one is small multiple. So first we'll look at what is a nested table. Okay. So in Tableau, a nested table, a table in Tableau, table is a collection of fields in rows and column shelves. So this is called a table, right? This is called a table. So this is called a table in Tableau. So it's a collection of fields in the rows and column shelves, rows and column shelves. So, or a complete visualization is known as a table as well. So if we place one dimension inside the other dimension, then it is known as a nested table. So there is one dimension here. So if you place another dimension under this dimension, then this is called as a nested table. So first there are rules to build a nested table. The rule number one is we need to identify the inner dimension and the outer dimension. So if there are two dimensions that you want to show as a nested table, so we have to identify the inner dimension and the outer dimension. So the second rule is we have to place the inner dimension inside the outer dimension. First the outer dimension comes, then inside the outer dimension we will place the inner dimension. So will perform a task to display year-wise and quarter-wise total profits. Okay, to understand this nested table better. So the first step is to identify inner dimension and outer dimension. So we'll take order date to see year and a quarter. So year is a outer dimension, and once you double click on it again, so you will see a quarter. So quarter is a inner dimension. So uh, outer dimension is an year and inner dimension is a quarter. So if you place a quarter as a dimension under the year, so that is the inner dimension. So you are placing an inner dimension inside the outer dimension. So this is called as a nested table. Okay, so we can work with multiple dimensions in there are several scenarios. This is one such scenario. So what we have done, we have dragged year and quarter into columns, and now we will drag profit into rows. Drag profit into rows, and we will color code with profit by placing that into color shelf, and also we'll drag profit into label. Now what we have done is year is a outer dimension and quarter is a inner dimension. So we have placed inner dimension under an outer dimension. This is called as a nested table. This is called as a nested table. Okay, so to show the values only for minimum and maximum, so we are also having in between values. So if you just want to show a minimum and maximum values, you can go to label. If you have to click on label in the marks card, in the marks label, you have to click on only minimum or maximum here. So now we are able to see only minimum and maximum values in the view. So basically, with this example, we have seen how we have to build a nested table by identifying inner dimension and a outer dimension and placing inner dimension under a outer dimension like this. Right. So we'll perform one more task. So we'll display department wise. We'll display department wise, customer segment wise, and ship mode wise, and ship mode wise number of customers. Ship mode wise number of customers. Okay. So first we need to identify the dimensions: the customer ID, customer segment, department, and ship mode. So we'll drag department, customer segment, ship mode into rows. Department, customer segment, and ship mode into rows, and customer ID into columns. Right. So what is our task now? So to display department wise, segment wise, and ship mode wise number of customers. Here we have to change the aggregation to count distinct for customer ID. You have to go to measure, right click on the field, go to measure and select count distinct. So this will take only unique number of customers, and we have to color code with the customer segment to differentiate the view like this. Okay, for each customer segment we are showing a different color. For consumer we are showing blue, corporate orange, home office red, and small business a pale blue color or B color. Right. So here we have used multiple measures, multiple dimensions in rows to show unique the number of customers in each dimension. Okay. So there are three dimensions that we have used in the shown in the view. So the first dimension is the department, then the customer segment, then the ship mode. Okay. So this is how we can also work with multiple dimensions. Right. So we'll perform one more task where we will display year wise, quarter wise, and uh, month wise and day wise average discounts. Okay. So we will drag order date and drop it into rows for 4 times. We'll drag order date and place it into rows for 4 times. So what it is showing is year, quarter, month, and day. If you drag order date into rows for 4 times, right? Now we'll drag discount and drop it into uh, text or label of the marks card. Right. Now we are able to see here that we are showing multiple dimensions in the view at a single go. So this is also one of the ways to show multiple dimensions. We have to note here that the maximum level of nesting possible in Tableau is 15. So there are 4 number of nestings here, right? So obviously 3 numbers. So along with 1, so the formula is n minus 1 to show number of maximum level. Okay, so here 4, so n minus 1 is 4 minus 1 is 3. So the level of nesting here is 3. Similarly, we can show maximum number of nesting which is possible in Tableau is 15. That because maximum number of fields that we can show or place either in rows or column shelves in Tableau is 16. So we can show 16 dimensions. So the maximum level of nesting possible is 15. Okay? The formula is n minus 1. So 16 minus 1 is 15. So you can use 16 fields in either rows or columns. Okay, so it is possible to take more than 16 dimensions also in rows and column shelf by modifying the XML code of the workbook. So if you want more number of dimensions in the view, okay, it is also possible by modifying the XML code of the workbook. So we have to save it as save it as TWB, only TWB. So I've already discussed in the previous class that if you save it as a Tableau workbook by extension .twb, it will be saved as XML code, XML file. So if it is saved as an XML file, so you can modify the XML code and then increase the dimensions as well. So we'll see that later. Okay, now so in this weekend, so you need to actually do some assignment tasks as well. So we have done 3 tasks. So I'll give few more tasks to you, which is you need to display year wise, month wise, average profits. Okay, task 2 is please do this over the weekend and submit me by replying to the mail. The task 2 is you need to display department wise, and category wise total order quantity. The task 3 is display country wise, state wise, city wise, postal code wise. Maximum profits in the form of a text table. And the last task is to display year wise and continent wise average margin. Okay, okay. There is product based margin here, so you can use that. Right, these are the tasks. I'll share this with you. So these are the tasks you have to perform over the weekend and submit as an assignment.
How do we send it to you? Like, is there a thing like we can save the Tableau and send it to you?
Yeah, yeah. You save the book as Tableau TWBX after you are done with the visualization building. Yeah,
Okay.
so you'll be working on Tableau desktop like this, right? After you're done, go to File and save as .twbx. Okay.
Okay.
Once you save it, so it will be saved as a desktop file like this. Okay, it will be saved as a packaged workbook like this. Okay,
Okay.
so copy this and then email it to me.
Okay.
Right. So I'll send this exercise task to you over the email, so you can refer to that. Right. So I've told you that in Tableau, to work with multiple dimensions, we have two ways. One is nested table, and the other is small multiple. Okay. So we'll look at small multiple now. So we'll look at small multiples now. If we break down the visualization into multiple parts by multiplying the dimension with measure, then such kind of a visualization is known as a small multiple visualization. Okay, if you break down the visualization into multiple parts by multiplying the dimension with measure, by multiplying the dimension with measure, then such type of a visualization is known as a small multiples visualization. Okay, so we'll see that in detail. So it is also known as a panel chart. It is also known as a panel chart. So to build a multiple measure, small multiple visualization, there are also two rules to it. So one is to identify small multiple dimensions and normal dimensions. So we need to identify, the first rule is to identify small multiple dimensions and normal dimensions. And the second rule is we need to place the small multiple dimension along with measure. The second rule is we need to place the small multiple dimension along with measure. So we'll perform a task. We'll perform a task now. So we'll be displaying year-wise sales in every quarter. So we'll drag order date into rows, order date into rows, and sales into columns. Sales into columns. Okay, right. So we'll drag order date and drop it into columns and change the date level to quarter. We'll drag order date and drop it into columns and change the date level to quarter. In color code with sales. So here we also have to have order date as year here. Right. So if you break down the visualization into multiple parts by multiplying the dimension with measure, okay, we are multiplying the dimension with measure, right? Then such kind of a visualization is known as a small multiples visualization, or this is also called as a panel chart. So we have identified a small multiple dimension and a normal dimension. So the normal dimension is a small multiple dimension. So we'll placing the small multiple dimension along with a measure. Okay. So what we are doing here, so we are displaying year-wise sales in every quarter. So we are displaying year-wise sales in every quarter here, or you can look at the view like this. So in each year, so we are showing we are displaying year-wise sales in every quarter. Okay. So what we have done, we have dragged the order date into rows, and here like this, here we have dragged the order date into rows and sales into columns. So we have dragged order date again and dropped it into columns and changed the level into quarter, and we are color coded with sales. So this has created uh, small multiples of a visualization. That is, we are uh, we are multiplying the dimension with measure. Okay, here we are multiplying the dimension with a measure like this. So we'll perform another task. So here we'll display continent wise total sales in every customer segment. So we'll drag continent into rows, and then profit into columns. So we'll drag customer segment and drop it into column and color code with profit. Right here, what have we done? We have multiplied multiply dimension customer segment with measure profit. Okay, and we are showing it by different continents. Okay, so in each continent by customer segment, these are the profits. So this type of a panel chart is called as small multiples. Okay, right. So we have to note here that in Tableau, it is not possible to place a dimension to the right side of the measure because all the measures are dependent on the measures. So as you can see here, it is not possible to place the dimension to the right side of the measure. So when I've tried to drag drop this dimension to right side, I was not able to do that. In Tableau, it is not possible. The reason is because all the measures are dependent on the dimensions. All the measures are dependent on the dimensions. So first we have to show the dimension and then the sales. Okay, so because sales are dependent on the customer segment here. So for example, if I try to drag drop customer sales into right, I'm not able to do that. So by default, the arrow is showing to the left of profit. So even though I'm placing the customer segment to the right, so the arrow is showing to the left. So however, if I do the same under just beside a dimension, I'm able to see the arrow before just after the continent on the right side. However, am I able to do the same in the case of a measure? No, right? So even after placing the dimension onto the right, I'm getting an arrow to place it onto the left of left of the profit or a measure. See, if I place it here, so I'm getting an arrow mark to the left. If I'm placing it here in type of a dimension, I'm getting the arrow mark to the right, left, right. I'm not able to have the same functionality here in the case of a measure. Okay, so in Tableau, you have to note that it is not possible to place a dimension to the right side of the measure because all the measures are dependent on the measures. Okay, dependence on the dimensions. Sorry, all the measures are dependent on the dimensions. So in this case, the profits are dependent on the customer segment. Even though if we try to place any dimension to the right side of the measure, Tableau automatically places it in the left side of the measure. So if even though if you want to try to place the dimension to the right side of the measure, Tableau automatically places it to the left side of the measure. Okay, so we'll perform another task here. Now in this task, we'll try to display category wise, ship mode wise, and shipping cost per region. So note here that the shortcut to find out the number of panels, panes or panels is, so number of values in each small multiple dimensions into number of measures into number of values in each nested table dimension except the innermost dimension. For example, uh, number of values in each small dimension is 5 and the number of measures is 1, and the number of values in each nested table dimension is 17 except the innermost dimension, then 15 into 1 into 7 is 85. So that is a shortcut to find the number of panes or panels. Okay, so what is the shortcut to find the number of panes or panels? Number of values in each small multiple dimension. Is what number of uh, values in each small multiple dimension into number of measures into number of each nested table dimension, number of values except the innermost dimension. So for example, the number of values in each small multiple is say 5. Okay, and the number of measures is say 1, and the number of values in each nested table is say 17, and so the number of panes or panels is 85. This is a shortcut to find the number of panes. Okay, so with only one dimension, with only one dimension, the value, the formula is the number of values in small dimensions into number of measures with only one dimension. So um, with only one dimension, so with only one dimension in this scenario, so here we can calculate by this formula. So number of values in small dimensions into number of measures. Right. So we'll perform this task now. So we'll drag uh, category and ship mode into rows. So our task is to display category wise, ship mode wise, and shipping cost per region. Okay. So we'll drag ship mode into rows and category into rows. And then shipping cost into columns. So we'll drag region and drop it into columns. So we'll display country wise. So sorry, we'll display region wise uh, shipping cost divided by category and ship mode. Okay. So basically, we are multiplying the region with the shipping cost, right? So this is one of the ways that we can show small multiples. So you can also show by clicking T to show text. So we have category and ship mode divided by the region shown as um, shown shown as a shipping cost divided by region, like this. Okay. So we'll perform one more task. So we'll display country wise, department wise number of customers in each customer segment. So we'll drag country department into rows. Drag country into rows. And department into rows. And customer ID into columns. We click on add all members and change the aggregation to distinct count. Right. So we have distinct count shown by country and department, distinct count of customers. So we'll drag customer and drop it into columns. So now the aim is to show uh, country wise, department wise number of customers in customer segment, in each customer segment. So we'll first color code with number of customers. We'll take aggregation as count distinct. So we'll color on marks card, edit colors, and click on, we'll go to colors, click on edit colors, we'll click on reverse and apply OK. we'll also show customer segment here. So here in this example, we have shown uh, country wise and department wise number of customers in each customer segment. So we can show data like this. So you can also show it in text if you want, like this as well. So this is country and department wise, uh, count of customers by different customer segment. So if you remove this, so you will have only total customers. So if you divide that, you have it by customer segment, right? So if you want to be this side, so you will be having it in a visualization like this. Okay. So here, so if you exclude the country, if you add a filter and want to show only for US, so you'll have a better visualization. Okay. So because we have a lot of data for US here in this way. Okay. Like this, you can show the data. Right. So we'll take a small break here, and after that, so we will continue with the remaining tasks, and we'll also look at how to handle more number of dimensions in the view, if it is 16 or more than 16. Okay, we'll meet after a couple of minutes. The next task, we're going to perform a visualization to display year-wise, month-wise, and item-wise average discounts in every department and continent. So we'll display year-wise, month-wise, and item-wise average discounts in every department and continent and department. So for that, so we will drag order date into rows for 2 times for getting year and month. So we'll drag order date into rows for 2 times. So we'll get year, and the next hierarchy is quarter. So we'll select year and we'll change quarter to month, because we want to see year and month only. And we will drag item and drop it into rows. Okay, we have year, month, and item. And we also want discount. So we'll drag discount into columns. So we'll change the aggregation from sum to average, because we want average discount. And we'll show the text by clicking on T. So we don't want the format to be in this way. So we want average discount to be in percentage. So we'll go to discount, right click on the field, in default properties, we'll go to number format and change it into percentage, and decimal places is 1. So that will change the percentage to the average discount to percentage like this. Right. Now we will drag department and continent into columns to subdivide this further. So we'll drag department and continent to columns. So now we are able to see uh, year-wise, and month-wise, item-wise, average discounts in every department, and continent. So this is a way you can show this much amount of data in a single view. Okay, so these are the few tasks that we are using as some examples to understand multiple small multiples. Okay, so You have few more tasks to do, so I'll give you some assignments. So this is for this is for the first set of example assignments is for nested table. And this is for small multiple. So you need to display quarter wise, month wise, number of um, order quantity in every category. Quarter wise, month wise, in every category. Similarly, also perform another task to display month wise need to display month wise, week wise average, average order quantity in every state. So the next task is to display country wise, state wise, city wise, maximum profits in every month and region. And one more task. So you need to display department wise, category wise, container wise, no, continent wise, item wise, total sales in each month and customer segment. So you please perform this assignment task and then send it across to me. So 4 tasks in nested table and 4 tasks in small multiple. Okay. I'll share this with you. So now we are going to perform a task um, to increase the dimension limit. So increasing the dimension limit in rows and column shelves. So we have seen that. So we cannot add more dimensions into rows or columns more than 16 in number. So if you want to add 17 or more number of dimensions, Tableau doesn't permit it. So we'll see that in detail. So by default in Tableau, we can place only 16 dimensions into rows or columns. So to place more than 16 dimensions, we need to change row and column limit in the XML code of the workbook. Okay, we'll see that. So by default, Tableau will accept only 6 dimensions at a time into the rows or columns, because in table layout options, the default value has set to 6. So if you open a new window, a new sheet, and if you select number of dimensions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you have to press shift to do this, and also press control and then drag them onto rows. So you are able to see 1, 2, 3, 4, 5. 5 fields are appearing properly. From the sixth field, all the remaining fields are combined and shown it in a single view. Okay, so by default, Tableau will accept only 6 dimensions at a time into the rows or columns, because in table layout option, the default value has been set to 6. So we can place more than 16 dimensions also into a row and column, but Tableau will replace older dimensions with the newer dimensions and keep only 16 dimensions. So first, go to analysis, go to table layout, and go to advanced. And as you can see, by default, uh, in table options, the maximum levels of row labels and also column labels is 6 here. This is the default set. That's the reason why we are able to see only 6 fields here, and in the sixth field, all the remaining fields have been combined into a single field. So we can increase this to 16, maximum 16. Can increase this to 16. Okay, we increase this to rows, horizontal row labels, maximum of labels, and maximum number of column labels. We have increased this to 16. 16 is the maximum number, and we'll click on apply here and see the difference and click on OK. So are we able to see all these in a single view? Yes, right? So uh, by doing that, we can see maximum of 16 dimensions. Okay, we will add. So we'll see what is the last row ID. Row ID is the last field that we have added into the view. So we'll add few more. So by adding few more than 16, so uh, those are combined into a view. So if you, so we have set the maximum number to 16 from 6 by default. By default, Tableau will accept only 6 dimensions at a time into the rows or columns, because the table layout, in the analysis, we go to table layout. Okay, in table layout options, the default value has been set to 6 in the first place. So go to advanced, it was 6. So we have increased it to 16. By increasing it to 16 and pressing apply and OK, so we are able to add 16 dimensions in a view. However, if you want to add more than 16, So then again this issue is arising. Okay, so now by default Tableau we can place only 16 dimensions into rows or columns. So to place more than 16 dimensions, we need to change row and column limit in the XML code of the workbook. So we need to change the XML code of the workbook. Okay, so first we need to save this as TWB. So by saving this as TWB, it will get saved as a XML file. So now what we'll do is, um, here we wanted to place 17th dimension table. Okay, so when we wanted to place a 17th dimension table, it will replace the first with the 17th dimension. Okay, and also 17 plus dimension, then to display from 2 to 17 only. So the second to 17th will be displayed in the view, and rest of all after 17, that we have added 3 rows, right? 17, 18 and 19th dimension into the view, all are combined into the first views, and then they are shown. Okay, so for that, so what we have to do is, um, we need to save this as a XML, save it as a TWB file. So by saving it as a TW file, um, it will be saved as a XML file. So we'll go to that view, and then right click, and we'll select open with Notepad. Okay, open with Notepad. So this will show you a XML code like this. So after saving it as a .tw file, we have to select open with Notepad, in Notepad. Okay, so in Notepad, what we have to do is we have to click on Control. Um, we have to click on Control F. We have to click on Control F to find column level. So in this window, uh, okay, so in the Notepad, we'll click on Edit tab. We have to click on Edit tab here. Okay, then we have to we have to select Find. We have to select Find. Okay, in the Find window, we have to enter column value, COL column value, column level. Sorry, column level. So we'll be able to see that the code is written to show the maximum of 16. Okay, the by clicking on next, we'll see that the levels are till 16 only. So we will increase this to 30. We'll increase this to 30 now. So we don't want to change this. So we just want to see. So here we are using rows. Okay. So in rows, we'll change it to 30. And then file, click on save. Click on file and then click on save. We'll close the notepad and close the workbook as well. Okay, so by doing this, what happens is we will be able to add more than 16 dimensions into the view. So if you change the XML code of any workbook, it is specific to that workbook only. So if you again reopen the workbook, it will display all the dimensions. So 16 plus dimensions in the view. So if you change the XML code of any workbook, it is specific to that workbook only. It is specific to that workbook only. So in our next task, what we'll do is we'll design a bar chart to display only borders with transparent inside and also show values inside a bar for region wise total sales. So in this scenario, what we'll do is, so we'll design a bar chart to display only borders with transparency inside and also show values inside the bar for region wise total sales. So for this, we will drag region into rows and then sales into columns and click on descending order. Descending order in the toolbar. So in marks card, we'll click on color and select color as white. Okay, and this will display all the rows bar charts in white. And under FX, what we'll do is we'll select border. We'll select border and select the color as orange. So we will drag region into label of the marks card. Okay, we'll drag region into the label of the marks. So what have we done? We have changed the color to white and added borders for region and added the region for text or label. So we'll click on label and in alignment we'll select horizontal central, horizontal center. So that will place the labels in center of the bar graphs. Okay, so by this way, what are we trying to do is we are trying to design a bar chart to display only borders with transparency inside and also show values inside the bar for region wise total sales. Okay, so we can also display a view like this. So we will also relook at the parts of the data view. So we'll also look at the parts of the data view. So um, first we'll look at the table. So what is a table? Table is a visualization or it's a collection of fields in rows and columns. So header, what is a header? So header is values across dimensions. So headers are values across dimensions. So axis, what is an axis? Axis are values across the measure. So axis are values across the measure. So this is an axis, right? So axis are the values across the measure. So we also have pane here. Okay, so if you add in one more dimension, country, we'll have a pane here. Okay, or we can add category here. Okay, so this is a pane. So this is a pane. What is a pane? It is a subset or subpart of the table. A pane is a subset or subpart of the table. A pane is a subset or subpart of the table. So we will also see cell. Cell. What is a cell? Cell is a subpart of a pane. So within pane, each cell is a subpart of a pane. So it's a each individual row. So what is a field label? So field label is nothing but field name. So this is a field label or field name. It is also called as a field name. So what does a marks card do? A marks card, it will show the required information. What does a marks card do? It shows the required information. So we also have legend. So uh, so in a view, if you show coloring, so we'll have a legend like this. So what is a legend? So these are objects. So this is the different colors that we use to to show or demarcate the members with different colors. So these are the objects in the view shown with different colors. This is shown in the form of a legend like this. So we have title. So we have title of a sheet. So we can rename the title as well here. So this is a title of the sheet. Okay. So this is a title of a sheet. So we also have a caption. So we can add a caption. So we can write a note uh, under the view with a caption. So we can add a caption under the visualization as well. So we can also show summary. We can also show the summary of the view. Okay. So by showing a summary, we'll get uh, the count, sum, average, minimum, maximum, medium of the field that is there in the view. So here, customer ID information. Okay. So these are the different parts of the data view. So this is about working with multiple dimensions in a visualization. Now we'll discuss uh, the aspect of working with multiple measures. So in Tableau, to work with multiple measures we have three ways. So in Tableau, to work with multiple measures, we have three ways. So one is individual axis. One is individual axis. The second one is blended axis or axis blending. And the third one is dual axis. So there are three ways to work with multiple measures. So till now we have seen how we can work with multiple dimensions. Now we are going to see how to work with multiple measures. So in Tableau, to work with multiple measures, we have three ways. Individual axis. So measures are shown in axis, right? So we have individual axis, which is single axis. We have blended axis or axis blending, and we also have dual axis. So we'll see what is the individual axis. So if we represent each and every measure with a separate axis, then such a kind of a chart is known as a individual axis. So if you represent each and every measure with a separate axis, then such kind of a chart is known as a individual axis chart. In individual axis charts, Tableau will create a separate marks card for every measure. So you will be able to see under marks card, separate marks card for every measure. For every measure, you will be able to see separate marks card for individual axis. So we will perform a task to see that. So we will display year-wise total sales and total profits. So we will display year-wise total sales and total profits. So we will drag and drop order date into columns. So this is year-wise order dates, and sales into or profits into rows. Okay. So we'll also create sales here. So by default, Tableau creates individual access for both sales and profits. So we are able to see that by default, Tableau is able to create automatically two individual axes, one for sales and one for profit. Click on sales marks card. So I've told you that uh, in individual axis, separate axis will be shown. Okay, so even under marks card, you will have two marks cards, one for sales and one for profit. Okay, before adding sales, for you are having only one marks card. So if you add sales, you will get two marks card, one for sales and one for profit, like this. Okay. Okay, click on sales marks card, click on the sales marks card and drag sales and drop it into color. Drag sales and drop it into color like this. So click on profit marks card and drag order date and place it into color. Okay. So drag the color window and drop it into the right side of the visualization. So you can adjust this color windows as you want. So you can drop it into the left side also, the visualization, left or right as per your need. So you can also drag it under here. So basically this is called as organizing the workspace. So you can organize the workspace by adjusting the legends and colors on the view. Okay, so basically here you can change it to profit as well. So if you don't want to show this value, so you can add a profit here. Okay, or you can have the years as well. So this way you are able to see individual axis. So we'll perform one more task to understand this better. So we'll display continent wise, customer segment wise, total profits, average profits, minimum profits, maximum profits. So we'll color the visualization with continent. We have to note here that Tableau will create a separate marks card for each and every axis. Similar to the this above example, this example, it will create separate axis, separate marks card for each and every axis. We'll drag continent for separate axis for continent segment. Okay, so we'll see that. So we'll drag continent and customer segment into rows. Then profit into columns. So we'll drag profit and drop it into columns for 3 times. So what do you want? We want um, total profits, average profits, minimum profits, and maximum profits. Okay, so total profits can be derived from sum of profits. So to get average, you want to change the aggregation to go to measure and then change it to average. For minimum profits, you have to change the aggregation to minimum. For maximum, you have to change it to maximum profits. Okay, right. So basically we have changed the aggregation for profits, average profits, minimum profit and maximum profit. So we'll drag continent and drop it into color of the all marks card. So we also have all marks card here. So here we'll drag continent and drop it into color. Okay, for each continent we have a single color here. Right. So we'll press T to show the text. So in this view, we are able to show separate marks card. So this is called as individual access charts. So we have separate marks card for each and every measure, each and every measure. So this is how we can work with multiple measures in a view. So in our earlier tasks, we have seen how we can work with multiple dimensions. Similarly, we can also work with multiple measures. So this is how we can work with multiple measures. So we'll perform one more task. So we'll display year-wise, month-wise total profits, average profits, maximum profits, and minimum profits. We'll drag order date and drop it into column for 2 times to get year and month. Change the value to month here. So we'll drag profit and drop it into rows for 4 times. And change the aggregation of 3 profits to average, maximum, and minimum. On the all marks card, we'll drag profit and drop it into color. Okay. So here also we can edit different colors. So for profit, we can take red to green diverging. So red means it's a negative profit, green means it's a positive profit, like this. Okay. So for each measure we have separate marks card like this. So we can change the color, change the view and stuff like that. So we are able to show individual axes like this. We have to note here that in individual axis charts, Tableau will display each and every measure on a separate pane with a separate axis and separate marks card. So we are able to see here that in individual axis charts, Tableau is displaying each and every measure. So these are all the measures, right? 4 measures. So they are separately displayed with separate pane. So these are panes, separate panes and separate axis. So these are having separate axis. See, these are having separate axis, right? So no axis is similar. So they are having separate axis for each of them. So the values are also separate, right? Because the aggregation is completely different. This is sum of profits, total profits. This is average profit. This is maximum profit and minimum profit. This is having separate axis altogether. Okay, and they are also having separate marks card. So along with all, we have having separate marks card for sum, average, maximum and minimum. Okay, for individual axis charts we have such a view. Okay, also note that the number of marks card in individual charts is n plus 1, that is n is number of measures. So number of marks cards is n plus 1. So because we also have all marks cards. Okay, so if you have 4 measures, we'll have 5 marks cards because we also have all marks card here, right? So we have uh, blended axis or axis blending in the next type. Okay, so we'll see what is a blended axis, or this is a individual axis charts. We'll see what is a blended axis chart. So blending means mixing, right? What is blending? Blending is nothing but mixing. If we combine multiple measure axis into a single axis, then it is known as a blended axis. So if you combine multiple measure axis into a single axis, then it is known as a blended axis. So we'll perform a task. In this task, I'll show year-wise total sales and total profit in the form of a blended axis. We'll drag year into column and then sales into row. So we'll drag profit and drop it into existing axis. Okay. So what we have done is, so I'm just undoing this. What I've done is I've dragged profit and place it into the existing axis, which is sales axis. By doing that, so it is not creating one more axis. Rather than that, it is actually blending with the already existing axis called sales and creating a blended view. Okay, it's creating a blended view or blended axis. That means on a single axis, Tableau is representing 2 measures, and the rows has been changed into measure values, and in measure values we are able to see profit and rows as separate. See, I'm undoing this. So before there is only sum of sales. By placing profit onto the same axis, this observe that the sales will be converted into measure values, and a measure value um, card will be created here wherein it will have sales and profits. Observe this. Here measure values has been created with profit and sales, and the sum of sales has been converted into measure values here in under rows. And rather than creating 2 different individual axes, a single axis has been created uh, in which 2 measures have been showed as a blended view, right? right, we have dragged profit and dropped it into the existing view. So Tableau automatically performs axis blending by using measure names and measure value fields. So measure names and measure values. So under measure names, so it is uh, placed on in color, and in measure values it is placing under rows. So Tableau automatically performs the axis blending by using measure names and measure values. Okay, measure value fields, these two fields are automatically created when you blend axis. So we have to note here that in blended axis, Tableau will combine and analyze multiple measures on a single axis, okay, and on a single pane. So we are having only one pane here, we are only also having only single axis here. So in blended axis, Tableau will combine and analyze multiple measures on a single axis and a single pane. Okay, so we'll see blending internal mechanism, how it performs. So before blending and after blending. I'm duplicating this sheet. So, so before blending, we have this view where we have years. Also, we have sales here. So we have a line here. So, so during blending, we are dragging profit into existing sales axis. So we are dragging profit into existing sales axis and just placing it here like this. Okay. So this is creating a measure names. Okay. Measure names is has having sales plus profit. So it contains names of combined measures. Okay. So the measure names, these measure names, sorry, these measure names is having sales plus profit. So it contains names of combined measures. So in measure values, it also contains sales values and profit values. Measure values contains sales values plus profit values. It contains values of combined measures. In measure names, it contains names of combined measures. So after blending, the view will be like this. So view will be of measure values and the same years. However, you have two lines, one for sales and one for profits. Okay, so you can use measure names to show in label also. So this line is for sales and this line is for profit. Okay, this line is for sales and this line is for profit. You have to note here that measure names and values are the default fields created by Tableau with every data source in the Tableau workbook. So measure names and values are the default fields created by Tableau with every data source in the Tableau workbook. Okay, so this is about dual blending axis. So we will perform few more tasks in our next class and continue with the blended axis and dual axis as well. Okay. So we'll also cover combination charts. We'll also cover combination charts and combination axis charts also in our next class. Okay. So that's it from my end for today, guys. So do you have any questions till now?
No, I'm good. Thank you.
Okay. So yeah, I'll be sharing the assignments. So over the weekend, so please work on the assignments and please submit that to me by
When do you need
Monday.
it by? Like, is it a particular date you want them by?
Yeah, by Monday your time, by Monday
Okay,
morning. Okay,
got it.
so you can work on Friday, Saturday, and Sunday. So we'll meet next Monday. So by next Monday, if you can submit that, that's okay. Okay.
Okay, sounds good.
Okay. See you next week then. Bye bye.
Bye, Kranti. Bye.
Bye.
Bye.